All right, hello everyone and good morning and welcome to our annual MSBA 2025 Applied Project Showcase. Our agenda for today, we'll have presentations. 10 teams will be presenting their year-long culmination of work in the Applied Project Program as part of the MSBA program, which we'll talk about shortly, and also presenting a live demo of their prototype solution to help to solve their organization's business problem utilizing the organization's data. The presentation duration is approximately 10 minutes with an allowance for 5 minutes of Q&A. And we will take 10-minute breaks throughout. So that'll be the first half of our day from 9 a.m. to approximately between 12 and 12:30. We'll have a break for lunch between 12:30 and 1:30 p.m. And then our second part of the day of the showcase will be our interactive poster session where all of the student teams will be stationed in the hallway with their posters, and that'll be an opportunity for you to interact with them directly and ask them more in-depth questions and discuss their presentations, their digital transformation solutions, as well as their journey through the program. And that'll be from 1:30 to 3:30 p.m. right here in the hallway outside the room of the first floor of Milgard Hall. A little bit about the program as we talk about the journey that our students have embarked on and that they're nearing completion of. The MSBA program at the Milgard School of Business here at UW Tacoma, it is a certified STEM program. It is a hybrid work-compatible program where we have synchronous class sessions on Saturdays and asynchronous and online content and office hours and instruction and team interactions that occur on weekday evenings. It is a 12-month program, full-time program, 40 credits in length. Some of the courses, as an example of the type of work that our students and study that they've embarked on over the last 12 months, analytic strategy and big data management, business process and workflow analysis, business analytics, applied regression models, analytical decision-making, and data and text mining, among others. And what we're here to talk about and highlight is their year-long course series, their Digital Transformation Lab applied project course, in which students were paired with an organization and had an opportunity to actually utilize the organization's data to solve a business problem that could benefit from a data-driven solution and deliver a proof of concept prototype, again, which they'll be demonstrating here for you today. So a little bit about the journey that they've been on specifically in the Applied Project course series. As it's a 12-month program, 4-quarter program, the Applied Project course series is divided among 4 different phases. Phase 1, when the program begins in summer, is entirely dedicated to business discovery, which is engaging in market, company, and industry analysis, as well as focusing entirely on, as part of business understanding, focusing on scope management and scope definition. In autumn quarter, Phase 2 is data discovery, when the student teams had an opportunity to extract data directly from their clients and start to begin data exploration and perform their data visualization, descriptive and diagnostic analytics. Phase 3 in winter is data modeling, to where the students utilize the organization's data to create a predictive and or prescriptive model related to the business problem and development of their solution. And then in Phase 4 in spring, which we're going to see the penultimate outcome of today, is deployment, translating their model and integrating it into a digital transformation solution. Before we begin, I would like to give a very, very big thank you, first and foremost, to our Applied Project sponsors for this year. Without your help, essentially, and your willingness to give your time to mentor and support our students throughout this journey, it wouldn't be possible. So I want to thank, and I want to call out each one individually to do the best I can to give them the credit that is more than well-deserved for their contributions to our students and to our program. It's the Seattle Mariners, Sound Credit Union, University of Washington Tacoma, the University of Washington School of Medicine, ISIP, the International Society of Service Innovation Professionals, Greentrike, Curry and Brown, Providence, Virginia Mason Franciscan Health, and the WIAA. Again, thank you so much. We are more than extremely grateful for your time, your mentorship, and your contributions to our students and our program. All right, with that being said, I will go ahead and turn it over to our first presenting team, which is Project Team 1.
Good morning and welcome. Our team is excited to be presenting our work for Curry & Brown, predicting labor rates for union construction workers. My name is Jonah Jepson, and I'd like to introduce my teammates, Greg Stanek, Nathan O, Jaskrin Singh, and then not with us today is Suraj Judy. Curry & Brown is a professional services firm that specializes in construction cost management. Now, if you've ever done a home renovation project, you know that estimating cost and keeping your project under budget can be extremely difficult. Curry & Brown has to deal with this problem on a multi-million-dollar scale. As part of their efforts to increase their cost estimation and their accuracy, they brought us in to work on estimating labor rates. Specifically, they want to know is if using data pre-processing techniques like SMOTE or SMOGGN going to benefit and increase the accuracy of their labor rate predictions. Greg is going to walk you through our approach and our findings.
All right, thank you. So for our applied project, we followed the cross-industry standard process for data mining. And shown on the screen, I have a quarter-by-quarter breakdown of everything that we did. I highlighted a few key tasks that I'm going to go over with you guys today. Okay, next slide. Okay, so for summer quarter, we spent that without access to our data set. The only thing we had with us was the problem statement by Curry & Brown, and that was that their data set had exhibited significant issues with undersampling, which hindered their model's ability to learn from underrepresented classes. Okay, their suggestion was that we use SMOTE or SMOGGN to deal with this, so we spent a lot of time in summer learning about the SMOTE algorithm, which I'm going to talk a little bit about today. So if you look at the graphic up at the top on the left, the red dots are the underrepresented classes. And how SMOTE works is it randomly picks one of those, and then it finds the K closest class members using the K nearest neighbors algorithm. K is just a parameter, it's an integer. The one on the right, we picked 3, but you could have easily just picked 2, 1, whatever you want. And then it synthetically generates a data point halfway between that randomly chosen one and each of those K nearest neighbors. Okay, next slide. And then in the fall quarter, we got access to our data set, okay? We performed some exploratory data analysis. I put a couple graphics up that we used. So up at the top, those are our predictor variables. So you have location, which was broken down into state and city. There's trade, year, and level. And then at the bottom are the things that we're trying to predict. So up at the top is base, that's the base hourly rate of a union construction member. And then fringe, which are like the benefits that the company pays to them, such as insurance premiums, paid time off, things like that. One thing I want to highlight is the histogram of base and fringe. So we noticed that those looked like a pretty normal distribution. And that started cluing us in that maybe we didn't have an imbalanced data set like we originally thought. Okay, next slide. Okay, so then in winter quarter, we continue to develop our regression model and clean our data. So up at the top is the proprietary data set. Don't worry, I kind of shuffled it around, so you're not going to gain any insight from this. But in our cleaning, you can see that we did some feature selection. We eliminated city. We clustered everything on the state. We got rid of everything to the right, such as confirmed, union hall, hash ID. Those weren't useful to us. And then I highlighted in blue our 2 target variables we're trying to predict. And then what we did is we went to the Bureau of Economic Analysis and the Federal Reserve, and we added 9 extra data points that describe the economic conditions of each of the states. Okay, next slide. And then in the winter quarter, we continue to refine our regression model. So for our initial model exploration, we use Jump Pro. We like that because we could quickly try a bunch of different models. But for our final model development, we use the H2O AutoML package within R. So that's an ensemble method that uses the stacking methodology. All that means is that we fed a bunch of data into some smaller algorithms. We trained them, and then we took the output and we fed that into a final meta model. If any of that sounds esoteric, come find us at the poster session. We can spend a little bit more time and clear that up for you. And then we have our output here to the right. So specifically, what Curry and Brown wanted us to provide for them was only to estimate base. We also estimated fringe and a combination thereof, but this is our output of base. So there are three data sets that we fed into it. So on the left is the unmodified data set. The middle one is our smog or our smoke data set. And then the right one highlighted red is the added economic data. So first off, you can see that the smoke data set performed exceptionally poorly. We have a negative R squared. Our mean absolute error and our root mean squared error are really high compared to the other two. So we're not going to use that. But of note, we improved the predictive performance of the unmodified data set. Our R squared improved from 0.68 up to 0.796 for the just predicting base. And then with the combination of them, we improved it from 0.741 all the way up to 0.837. Okay, next slide. And then this last quarter in the spring, we worked on deploying our model. We used Power Apps to build our model. And up next, Nathan and Jas are going to take you through our application.
Yeah, so my name's Nathan. I'll be walking you through the Power Apps form that we developed for Curry and Brown to calculate their labor cost estimates with. Yeah, so the form is composed of 4 drop-down menus and 2 text labels at the bottom for each specific worker that's being employed within the project. So for the first drop-down menu, it's a simple state drop-down menu that takes all the values from our state column in the data set and offers them as options for you to choose in regards to the location in which the worker is employed in. And the second drop-down menu deals with the specific job title of the employee, also taken from the corresponding column in the data set. And yeah, from this, you're free to choose the job title of the worker that's currently being employed within the project. Third drop-down menu deals with the skill level of the employee. The most beginning skill level would be apprentice, which is at number 4, and the most advanced one, which is general foreman, at number 1. And finally, after you input in all the values for the drop-down menus, we have the 2 text labels at the bottom. The first of which deals with, actually I forgot the last drop-down menu, which is the year. You can choose the year 2025, which is obviously this current year, which Curry and Brown has wage rates for. And then the next years would be 2026 and 2027, which would be the future wage rates, which we were able to calculate using the ensemble method. And at the text labels at the bottom, the first one will be entering the number of this specific type of worker that's being employed within the project. And the next text label after that would be the number of hours that this worker is being employed for this project. And after you've inputted in all this information, you will click the Add Worker button, which would store these values that you've inputted into a table within the Power Apps form. And after you've inputted in all the specific workers that are being employed, you press the Calculate button, which then uses a lookup function based on all the drop-down values that you've chosen. And it looks up the specific wage rate that corresponds to that worker within our data set that we have, and it multiplies it by the number of workers and the number of hours and gives the total labor cost at the bottom. And in regards to our future plans with this form, we're planning on eventually incorporating overtime hours into this Power Apps form where we can select specific overtime wage rates for the various workers that are being employed based on the information that's given to us by Curry and Brown. And we're also planning on potentially using AI tools like ChatGPT or CoSuite to further automate the process to where Curry and Brown can use this AI tool to possibly analyze any spreadsheets or documents that they have to just automate the entire cost estimate process.
Thank you, team. Today we've shown that while SMO or SMOGIN may not be the right solution for Curry and Brown, using other variables, predictor variables, can increase their prediction accuracy. We've also shown how they can feed that information through a model and use that as a backend to feed a cost estimation tool that their employees can use. With that, we'd like to end our presentation and open the floor for questions. Thank you.
And we will proceed with Project Team 2.
You can walk over there. You can see the back. I'll click it. Actually, I need to see the content. Yeah, it's on the back screen. Is this over there? Okay. Hello. Okay. Hi guys, we are Team 2 and my name is Ishita Chaudhary.
I'm Mackenzie, this is Charlize, and then other members from our team are Jinzi, Tanya, and Priya.
Okay. We have been working with Greentrike, and as we all know that this is a part of our capstone project. Greentrike is a non-profit organization that operates on 2 locations. The first one is Children's Museum located in Tacoma, and the other is on JBLM. So the major challenge Greentrike was having that the data was scattered across multiple platforms and they were having difficulties to track activities. They were not able to measure their impacts and to make informed decisions. We have decided on the 2 project goals. First one was we had to identify a centralized system for them, and second one was we had to provide an interface for them in order to collect the visitors' data. In the 4 phase of this whole year, in the very first phase, we have worked on the scope and requirements, and we successfully verified the project scope and gathered clear, actionable requirements. In the second phase, we have delivered the interactive dashboard, which was user-friendly and empowers decision makers with actionable insights. In the third phase, we have performed a comprehensive data analysis by performing descriptive, diagnostic, predictive, and prescriptive analysis. We have built and implemented XGBoost time series model to forecast trends accurately. In the fourth phase, we have designed and deployed a digital form to streamline and standardize museum data, attendance data collection. I just want to conclude that at the end, we have just created a Power Apps visitor form for the future visitor of the museum to get basic information from the visitors and their feedback about their visit. Greentrike can use this form in their iPads to collect data, and this can be directly linked to their SQL database for further analysis.
Okay, we're gonna walk you through a quick demo of the prototype that we made for them using Power Apps. This form here essentially would be shown on they have little iPads that they use within the museums. So this would be displayed on the iPads that visitors would use to check in. They don't currently require any check-in process, so the way that they receive data is kind of hard and through a whole bunch of different systems. It's not anything centralized, as we mentioned before. So this kind of requires them to retrieve data. Since they have a pay-as-you-will system, this is something that I think is reasonable for them to require of their visitors. This form here, they'll just click this button to sign in. They'll fill out this form, which we've worked closely with Greentrike to determine what questions are most important to them and what are the things that they want to gain, demographic, and other information from their visitors to best track their impacts. We'll put in just a fake number here, just 1, 2, 3, 4, 5. One of the questions they wanted to know is what the family was most excited about visiting for today. So let's say that they wanted to use imaginative play. They have questions such as, do you want to receive email updates? This reflects for them to be able to take those emails straight out of the SQL that this feeds into to send them emails. If they want to provide feedback about their visit so they can improve the museums. How did they get to the museum today? This is something that helps see their transportation impact. So did they take a car? Did they take a bus? Did they travel with a friend? Where did they park today? Where are their visitors parking? Where should they keep their eyes on for improvements? If they had visited the museum before, this one is super important and something they've been having a really hard time tracking just from the different systems they're using. So this very easily lets them know if they're a returning visitor or a new visitor. If they knew about the pay-as-you-will admissions before they came in today, or if they expected to pay when they visited the museum. How did they hear about us? So why did they decide to come to the museum today? If they would recommend the museum to others, if they consider it to be part of their neighborhood, and if they follow them on social media. This date column, we're currently trying to figure out a better solution since they could select any date, but they would select the date that they're here. So this would also help them track their visitor count through different seasons a little bit better than the current system that they have. When they select the submit button, it will go straight into the SQL table that we created already. From this, we can see there's an email of 123, so this is a prior tester. So we can run it again to make sure that the form we just submitted went through. And it is on the second row there. And then also an example query that I have set up is being able to take and find those emails of the ones that said that they wanted to receive those email updates. So you can automatically pull those emails and send a bulk email for promotions. Another thing we have for the demo is if there's anything that's not entered correctly in the form, it won't let them submit it. So they pretty much have to do things correctly to get the correct data to prevent from having any inconsistent data in the SQL. It'll show a little error up here on the top. And that's all we have. So if anybody has any questions, we will open that up. Oh, yes.
I might have missed this part, but is there something to prevent dirty email data being entered in that field?
Not at this time. As you saw, I put 1, 2, 3, 4, 5.
Right.
So there is still a way for them to just put something null in there. I'm not sure of a process that there is to verify that an email is valid, but if we could figure it out, that's a good improvement to this. Thank you.
Test. I have a question. How are they currently collecting, or are they collecting visitor data?
They're not collecting anything when they come in. They have Square and Salesforce that they use when people purchase things, and they do manual head counts of people coming in. So that's how they track the numbers of people, and then they also have sign-ins for different classes that they do. So when they sign in for classes, they track the numbers in there, but they have a hard time connecting the emails and the actual unique identifiers of people and if they're revisiting, because they'll have 4 different forms of different activities and events that they had going on and don't have a centralized place to see, oh, this email also went to this event.
So it sounds like up to this point, they haven't had a way to accurately capture the data of all visitors and all traffic. Is that correct? Great. Great. Any other questions for the team? Excellent. Thank you very much. All right, and we have approaching Project Team 4.
Hello. Is it on? So hi everyone, I'm Prachi, and today I'll be kicking off our team presentation. We are Team 4, and over the past year, we partnered with Providence Health to optimize their workforce efficiency. Our goal was to turn their operational challenges into actionable and data-driven insights. Along with Providence, I got opportunity to work with my wonderful teammates here, Devon, Nandini, Virginia, Evelyn, and Kirti. So over the next few minutes, I'll walk you through the problem we addressed, how we tackled it, and the tools which helped us to develop the solution we provided. Then my teammate Nandini, she will take you through what we built and show a live demo and how everything comes together. So imagine two hospitals just few miles apart. They have same processes or same tools, but one is handling 5 times more workload with fewer staff. That's what we uncovered in the early stage of our project. So Providence was facing significant challenges in their workforce efficiency. Technician performance, it was widely contrasting. Scan procedures, they were not standardized, and inventory issues were leading to delays and stockouts. These were not just the technical problems, but they had impact on patient care and also the operational planning. So that's where our project started, to uncover what was really happening across their different sites, and then using analytics to make those processes more smarter and more consistent. So we began with our mission to help Providence to gain unified view of technician performance and their scanning operations. With this visibility, they could better allocate their resources, reduce any inefficiencies, and improve their supply chain performance. So this was the 3-part data structure which we used. Oracle, which served as the brain, centralizing all supply chain data. Then RF Smart, which serves as eyes, capturing all the real-time scan activity. And Genesis, which acted as a playbook, aligning all the, let's say, procedures across the different Providence locations. Together, this system's formatted foundation for our analytics and solution design in general. Then, for our next part, we prepared and collected structured data from multiple resources, then resolved any mismatches, and finally used Tableau to create a dashboard, which gave us a baseline to view the technician productivity and scan efficiency. From there, we used Python to build our predictive models, including XGBoost and ARIMA, to forecast the scan volumes and support the smarter staffing strategies, let's say. Here's how we progressed our project to different phases. We started with understanding the core challenge, We visited the hospitals, then observed the workflows firsthand, and that helped us to define our project scope and what the success will look like to us as well as Providence. So next we analyze for phase 2, next we analyze the technician and efficiency and inventory data. From scan logs to inventory, stock movements, everything. We built the visualizations, and then we could see the performance gap across the different campuses of Providence. Using these insights, then we moved the forecasting models to predict the scan demand, also the identify key workload drivers, such as what day of the work or type of the items which they were receiving. Finally, we translated these insights into actions just by building the interactive dashboards and the staffing simulation tool, which will help Providence in achieving what they are trying to do with this workforce efficiency. Moving on to the interesting part, I will hand over to my teammate Nandini, and she will take you through the demo and how everything comes together. Thank you.
Thank you, Prachi. Hi everyone, my name is Nandini. So now we'll be moving forward with a demo. So I'm excited to present our work with Providence that we have been projecting with to improve the scanning efficiency of the hospitals. So first we start with the dashboard of the total scans per hospital. So right with this dashboard, it's very easy to view that the topmost hospital comes as like Providence Everett, where like most number of scans are present, then comes St. Peter, and then comes Swedish Firstal. But does that mean that are these hospitals the most efficient? Wait, they are just like more number of scans are happening or like more number of technicians or staffs are there. It's not that when more number of scans are present, it's more efficient. So that's where we have solved this problem with developing a KPI called as scans per tech. So this scans per tech would be like calculating the actual technician scanning efficiency on an average basis for every hospitals. So as you can see, the topmost that comes here is Everett. It goes down when it comes to the scanning efficiency. So that's how the comparison of hospitals plays a role here and determines which is the most efficient and which comes under less efficient. So we have also given a detailed analysis of the daily scan trends per hospital and the daily scan trends per tech. So with this view, we would be able to help to know that which is the busiest day of a week where like most of the scans happen and like which person is mostly contributing towards the scanning. So next, moving on, we have like ranked the hospital performance ranking and the efficiency. So this is customizable where we can select like top 5 hospitals, top 10 hospitals. So this would help the stakeholders to determine not just like the busiest hospitals based upon the number of scans happens, but also the most efficient scans that is happening. So what we are developing here is like we are going beyond the number of scans happening. We are checking like not just how many scans are happening, but we are checking how well it is happening. So that's where we have taken about the average of like whether if this average line shows that whichever hospitals that comes above that would be considered as the best hospital, whereas the ones below ones, though the number is high, they're still like below the average. So next we have like taken another one factor in order to determine the efficiency, which is the time, scanning time of the. So here we can say that the most peak scanning hour of the hospital. So here we have taken the Firstal Hospital. So the Firstal Hospital has a peak scanning hour as 11 a.m. So usually these Providence hospitals, even for each and every hospital, they have a peak time, which we call it as a cutoff time. So some would have like 11 a.m., some would have like 2 p.m., 3 p.m. So whichever scans that are happening before that cutoff time is considered to be a good ones, right? Because whichever that is happening after that cutoff time is considered to be like, which are like lately scanned. So with this, we are able to come up like which hospitals, like whenever we select a hospital, whether they are coming like on time or whether they are like coming like delayed. So here we can see an example of Swedish Firstal of 2 p.m. and we can see only like 1% of scans are happening after 2 p.m. So this looks like it's actually like working. Their technicians are doing in a right way. We have also taken few hospitals for comparison, so which would say that whether their scans are happening on a delayed basis or on an on-time basis. So this trends, whichever we see the lines here, so the scanning trends would give us an idea that how is the hospital performing for an entire month. Is it like at the end of the month they are performing well? So as you can see, all the lines are gradually sloping downwards, so which means that their scanning time on the delayed, after the scans that are happening on delayed scans, they are actually quietly reduced. And this would also give a detailed breakdown about the breakdown per technician. So here we can say that after 2 p.m. we can say that there are few scans that are happening here. So we have the names and whichever persons that are doing. So this would give a one-on-one person a scheduling with those persons, like why those scans are happening like after the peak cutoff time. And lastly, we have also computed a perfect scan KPI. So this scoring is actually takes part of whether how the scans are happening. So we have classified into 3 types, which is which scans which are happening at yearly scanning 0 to 40%, then the late scanning which is 61 to 100%, and then the optimal scanning which is 41 to 60%. So what is this percentage denotes? So these percentages the bin capacity. So whenever a bin reaches 40%, whether they're scanning at that time, and those range come under yearly. Whenever the bin reaches after 60% and only that time they're scanning, they come under late. And when it is optimal, so we say it as 41 to 60%. So this is our perfect scan KPI scoreboard, and whatever the numbers that you're seeing here down, it denotes the perfect scan KPI, which is a combination of the scanning efficiency and about their acquisition patterns and the bin efficiency. So with that, we can see that even though the number of scans is with the topmost for Edmonds, but yet their scanning efficiency score is quite comparatively down when compared to other hospitals. So this gives an idea that not just the total number of scans is important to determine whether a hospital is efficient, but still certain other factors like bin efficiency and other capacity factors are required in order to determine the efficiency. And finally, we have a breakdown of technicians, so where it would give an analysis of whether they're falling under which category on a major basis. So whether each person, do they fall under late scanning or yearly scanning? And it also gives a weekly trend analysis and a monthly trend analysis. So this would give that, we can say that here this person has their scanning efficiency score down for Friday, 5 denotes a Friday. So why is there a slope down for that particular day? So is there a trend that is being following for all the months? So that's how we can come to know that whether they're actually efficient for all the days, or is that they're just throwing out the work for one day and they're just pushing out for the next week. So this analysis would give a detailed breakdown of the technicians, whether they're following the patterns and how is their efficiency going on. So with this said, we would like to take to the model. Yeah. So we have built our model, predictive model with Python. So I'm not just going to go through the code, but I would like to view the results how we did. So on a high-level basis, we have done our train and test split data for around January to October, and we have taken October month as a testing data set and the remaining months as a training. So first, we initially started with random forest model, and which we have got a score with after cross-validation. We have got a very good score of 0.95 after third fold. And now we moved on with XGBoost, as it works well with the structured data, and with which we were able to achieve a R-square value of 0.99. So after this, we have simulated and we have predicted for October. So we do have our October data, and we have predicted our results. And here you can see about this graph, where the red line says about the actual data for Providence for October, and the blue dot says about the predicted ones. So since they mostly lie across, it means that our model works well and it predicts correctly. So then we have after checking for 1 month, we have like simulated the data for the upcoming month. So our goal is to like, our client has provided the data for January to October, and our goal is to determine the number of scans and the number of technicians for the upcoming months as well. So with that, we have taken our feature importance, like the most important features are like item diversity, technician numbers, the average scans per tech, unit price, the weekend scan ratio, line quantity, weekday scan ratio, and lead time average days. So with all these said, we were able to like predict the scans over time for the upcoming months, and these are our results. So we have also like taken about a KPI called as productivity status. So whichever the model that we have developed, we have exported into the sheet, like whatever the data for each hospital. So as you can see, this is for Children's Hospital and this is for January month, and it says about whether their productivity status, whether it's efficient, but underutilized, needs improvement. So we have certain various factors like that. So with these said, we have taken as a baseline benchmark productivity. So we have taken top 10% of hospitals which are working very well across the US. We have marked them as a benchmark, and we are going to like use them for predicting our other hospitals for the upcoming month. So with that said, we were able to like predict the next month's scan. So this sheet predicts the scans for the November month. So where we can say this previous month's scans is for October and this predicted scans is for November, and it would also say about the estimated techs. So as you can see, the baseline is actually 9, but the estimated techs is only 6. So why is this coming as 6 is that we have taken in consideration with the best performing hospital and we've simulated with that as a benchmark. So with this said, we have also like developed an app which in Streamlit framework. So it's a Python framework where we have deployed our model that we have so far developed with our XGBoost. So with that, we are like giving the Providence a way to not just like go backwards, just react like how many scans have happened, but just they would also be able to like simulate like how many technicians or how many scans would happen in the future. So with that said, we have given 2 features. So one feature is that you can just select any one hospital from here, and when you click on predict, you will just get like how many scans, predicted scans, and how many estimated technicians are required. So this is done for a monthly basis. We also have another feature where you can enter manually instead of selecting the hospital. So this is a scenario where it's like a what-if scenario. So let us say that Cherry Hill Hospital at Seattle, they want to like increase the weekend shift. So in that case, when they increase it, and they also like wanted to like change the item diversity, they want to increase it, and they wanted to now predict like how many scans and how many technicians would be required for it. So these what-if scenarios will play a major role whenever they want to like change the weekend scan ratio, change the patterns, and see how it goes. So it's such a clean and simple tool which will help the stakeholders to just enter the business metrics and identify like what predictions will happen. Yeah. So this is our tool we have developed, and moving on to the recommendations part.
Thank you. So based on in detail data analysis Nandini explained, we were able to come up with a few recommendations, and which basically concluded that our predictive modeling works better with the season-specific alignments. And now we are happy to answer as many questions as you have. Thank you.
All right, I think what we'll do is we'll go ahead and take a break now. We'll take a 10-minute break. It's approximately, let's see, 9:45, so we'll resume at about 9:55. All right, everyone, we will go ahead and resume, and we will continue with Project Team 6.
Good morning. Thank you, everyone, for joining us today. We are Team 6. We are going to be presenting our applied project, which is a fraud detection model with Sound Credit Union. Just a quick intro to the team. My name is Megan, and my teammates are Nana, Ashi, Anna, and Neil. Over at Sound Credit Union, our day-to-day contact is Jason McDougall, and our executive sponsor for this project was Lyman Williams. Just a quick overview of what we're going to cover today. We're going to give you an intro to our project. We're going to cover the tools and solution architecture. We will show you our machine learning model results with a very quick Python demo. We will show you our performance tracking solution in Power BI. We'll discuss the outcomes and business impact. And then we will have time for a brief Q&A at the end. So Sound Credit Union is a local financial institution with over 170,000 members, and something that they care deeply about is member safety. They are interested in developing a fraud detection solution that will provide early alerts so that they are able to minimize the financial losses associated with fraud. So not only does fraud cost a lot of money, but it also costs a lot of money to identify. It can be very manual looking at the data and identifying accounts that may be engaging in fraud. Our method for this project was developing a predictive model that is trained on historical transaction data. This model is built to be integrated within Sound Credit Union's existing systems to provide account monitoring and alerts. So this has been a year in the making with 4 distinct phases aligning with the 4 academic terms. So over the summer during phase 1, we were really getting to know Sound Credit Union as a business, understanding their strengths, their opportunities, and how fraud impacts them. During phase 2, we moved into more of that exploratory data analysis. We received a very large data set with over 12 months of transaction data. We cleaned and profiled this data, creating a storage solution in Azure SQL databases. We also created Tableau dashboards that outlined account activity trends. Moving into phase 3, we started to do predictive analytics. In order to do this, we needed to address imbalanced data, so we wrote a Python script for that. And then we began testing different models using the Jump Pro software. And then what we're really going to be focusing on today is looking at what we've done in phase 4 to make this a high-quality, deployable solution. So we have continued testing our model. We have moved it completely over to Python to allow for greater customizability. We've also created documentation for deployment and maintenance of our model and created a Power BI solution for visualizing model performance. So looking at the tools that we used, we really wanted to use tools that our client was familiar with and that would come at a low cost to them. So for data visualization, we are using Power BI. We are using Python for standardizing data, for engineering features, and creating the model itself. We utilized Azure SQL databases for querying and analyzing our transaction data, as well as storing model performance data. And then we utilized Apache Airflow. This is a task orchestration tool that allows the model to run on a scheduled basis. Within the script we wrote for this, we also added features to generate notifications and reports. So how does this fit into our full solution? When a customer interacts with a banking product, that is being processed through the core banking system. From there, that data is what we are storing in our SQL database. Data from that database goes into the fraud detection model, which is activated on a weekly or otherwise specified basis using Apache Airflow. From there, the model results are stored in another database for further analysis and distribution. And then those results can feed into the Power BI dashboards to monitor performance as well as fraud trends and create internal alerts, whether it be via Slack or email. So a quick overview of our initial approach. We were using a random forest model. With this model, we introduced a framework to aggregate transactions at the account level. So we're not interested in looking at a specific transaction and whether or not that is a fraudulent transaction. We are looking at all of the activity of a single account and identifying whether or not it is likely to be engaging in fraud. Additionally, fraud is really rare, and that makes it difficult to train a model to identify it. So we utilized synthetic minority over sampling technique to account for that, to create some synthetic data to have a more balanced model. And this model performed pretty well. We had 78% accuracy, 43% of fraud was being detected, but we had a lot of false alarms. We know that this model is going to be iterated upon. We know that this is going to be improved over time. We want it to be trained on new data over time. So we knew that we could make it better, and we decided to start that process of iteration. That moves us to what ended up being our final approach, which is an ensemble model. So we are still utilizing that random forest model. It is great at capturing more broad patterns, but we're combining it with gradient boosting to help correct errors and detect more subtleties within the data. We use a method called soft voting. This averages the probability scores of the two, and this improved the overall accuracy, recall, and reduced false positives within the model. Some additional features we added more robust feature engineering. We have over 40 derived features, things like average balance change, things like average amount of transactions per branch at the account level. We also added feature selection to only select relevant features and remove all the extra noise. So we're starting out with those 40 derived features, and then we're ending, I believe, with about 19 in our model. We also implemented decision threshold optimization. So this is identifying that sweet spot in our model that will give us the highest amount of accuracy with the fewest false positives. The results for this were great. We got up to 88% accuracy with the ability to detect 51% of fraud. Compared to that first random forest model I showed you, this is a 13% increase in accuracy. We have 19% greater fraud detection capabilities and 54% fewer false positives. So for the business, what this means is we have greater confidence in this model's performance. We trust that it is providing high quality recommendations. We have a greater ability to detect fraud overall, and we don't have to spend as much in terms of resources looking at incorrectly flagged non-fraud accounts. So, since we plan on having this model be iterated upon and improved over time, we needed to create solutions for model performance tracking. Here we have two things. We have a results database. This stores model performance information from training and testing of the model, but it also stores the outputs, so the accounts that it is flagging and their probability scores. Additionally, something we'll be demoing for you today is we created a performance dashboard. So right now we have 2 data points in there from the 2 models that we demoed, but over time this could be iterated upon. This could even be trained on a weekly basis with the Airflow scheduler to have even more to compare. So we'll move into that quick Power BI demo. So what you can see here on the left side is these are individual metrics for a specified model. So right now I have it selected as the most recent model. It was trained on May 18th, but we could also look at the random forest model from May 1st. And we're able to see how it performs in terms of fraud detection, how it performs in terms of accuracy. Additionally, the ensemble model itself could have multiple iterations. That's why we're looking at it not just at the type of model, but at the date level. Additionally, on the right side, we have a comparison dashboard. So we have the ability to select multiple models and see how they stack up next to each other to see how our results are performing in comparison and whether or not we are improving. We can also select a date range. So if we only want to see models that were trained within the last month of data, we could do that as well. But overall, this creates visibility as these iterations come over time to seeing how our changes are actually creating results. So what does this look like for the business? We have increased fraud detection capabilities. With the ability to detect 51% of fraud cases, this model could potentially cut fraud-related losses in half. Additionally, this is reducing manual review time. So the process of doing a data pull, manually looking at all of these accounts would not be necessary, as this model can run automatically on a weekly basis, reducing the cost and the time burden. Additionally, this is a low-cost solution architecture. It's built off of open source technologies and tools that the business intelligence team is already using. No need for expensive software, no need for additional training. And finally, continuous improvement. So this model is designed to be continuously trained on new data, and we've provided documentation to support future enhancements and adaptability to evolving fraud trends. I like to say my favorite thing about this model is that it just keeps getting better. All right, thank you so much for everyone who has joined us today and everyone who has made this project possible. A huge thank you to the Sound Credit Union Business Intelligence team for enabling this project. We have time for a quick Q&A.
Any questions for the team? All right, excellent. Thank you very much.
Thank you.
All right, and going slightly out of sequence, next we have Project Team 5.
where hot dogs sizzle and beer flows like rivers of gold, one ballpark dared to defy expectations. Join us May 30th as data steps up to the plate. This isn't just about food, it's about patterns, performance, and the power of predictions.
That was great.
Hi, we are UW Tacoma's MSBA program team 5, and we will be talking about the Maryland's concession model. I'm Lorena, and I'll be talking about the business challenge. Ram will be talking about the 4 phases of our project. Tyler will give us a presentation on our dashboard. Hello? Ozge will be giving us a live demo of our model. Fulati will be talking about prescriptive analytics. And last but not least, Isaac will be talking about the challenges and our recommendations. So through the Milgard School of Business and Community Partnership, we had the opportunity to partner with the Seattle Mariners. The Seattle Mariners is a professional baseball team here in Seattle, founded in 1977. The Seattle Mariners lacked the precise forecasting that affected their ability to budget effectively and optimize sales strategies. This led to potential missed revenue. They needed to not only uncover the key drivers, but they also needed to be able to create a forecasting model that could predict going forward. Now I'll be followed by Ram, who will be talking about the 4 phases.
Thank you, Lorena. So as with all the business analytics phases, we started our project with these 4 phases. So we started our project on the descriptive and diagnostic phase, where we met with our stakeholders. Kobe and Mason are here. Thanks again for the ballpark ticket. So we went to the ballpark. We tried to understand the business model. We developed a project plan for us, developed an agile methodology, and we created a Kanban board. We defined the scope for all of us. And then we got into the initial data where we put our data into the R. We did the histograms, scatter plots to understand what kind of descriptive analytics that we want to do. Then we built our entity relationship model and brought that into the database. And then we moved on to the predictive phases where we deep dived into our data by running some predictive modeling. We went with all the algorithms, and finally we went with the XG boost algorithm, where that helped us understand what kind of feature are the best for us. So we built a predictive modeling using that, and then at final we jumped into the prescriptive model, where we developed a cognitive analytics solution where we are excited to show. So we created a shiny app that using the a priori algorithm, where we developed an association rule between all the products, and we estimated spending behavior, and we created a combo deals so that the best selling products and the other products can be combined, so the data can be, the sales drives can be better. So finally, all of these 4 stages, we incorporated Power BI dashboard, where we developed our metrics and analysis, which we are excited to show about, which Tyler will be walking through a live demo of it now.
Thanks, Ram. So our Power BI dashboard was built with the goal to provide a simple, accessible overview of sales while still allowing for the deeper dives into the drivers and the key drivers of those sales. The dashboard includes various, The dashboard includes various variables, such as the overall sales, the number of orders, and the attendance. These remain consistent throughout the report, while we can dive deeper into variable impact, attendance, and then there's a model that will go on here. And then I gotta switch this, hold on. You can't click in there, sorry guys. So all the visuals are interactive. We can filter by the section of the stadium, or the series, the homestand. The slicers are the homestand, which is the consecutive number of games played. So if we want to check out this number series 7, that will filter down. And then the series, so that's the team that they played there. We also have deep dives into attendance, impacts of variables, and then a integrated Python model, which Ajay will review now.
Thank you, Tyler, wrapping that up. Now I'm going to talk about our prediction model. Our goal was to predict the total sales. And then in our diagnostic phase, we did feature importance test, and we found out that attendance is most important features in our data sets. And then when we first train our model to predict total sales, we got 98% accuracy. And then we also train our model without attendance to see how can we accurately train our model. And we found out that 70% accuracy on that. And we built a two-step model solution. And then this was like first training the attendance model to predict attendance, and then feeding our total sales prediction model with the attendance. And then we found out that without attendance, 70% accuracy. So there is still room to improve, and we are looking forward to get more data to predict better for accuracy. Thank you, and now Flati will take over from here.
And good morning, everyone. Thank you, Özge, so much for showing us the predictive model. I am gonna present our team's prescriptive analysis we did. So the question here we want to answer is, how can Mariner decide which concession item to promote on each game day? So to tackle this question, we design a solution that combines machine learning, predictive association rule mining, and a real-time recommendation app. To begin with, we use the random forest to predict which category item is performing well and which are not, using the historical sales data combining with the game day features such as attendance, weather, day of the week, and temperature. Built on the prediction, we also used market basket analysis to understand fan purchasing behavior. And you can see from the graph at the right, the appetizer constantly worked as a central connector. Whenever an appetizer is bought, they often accompanied by a pretzel, non-alcoholic beverage, sandwich, or pizza. So this gives us a strong opportunity to create a bundle deal. So most important and exciting part is that we developed an interactive application that can help mariners to generate promotions. So let me show you guys how this app works. This is the app. Once you click in, it will ask for the input, the weather. We can assume it's sunny day at 70 degrees. Attendance with 35,000 fans engaging in the park on a Wednesday. Click on the generate. It will pop up. The primary suggestion is bakery with suggestion pairing with appetizer. So we believe with this application, mariners can make more data-driven decision on promotion strategy. Now I'll pass it on to Isaac to wrap up the project. Thank you.
Thank you, Fulati. When looking ahead, we set our challenges, successes, and our recommendations to them into 4 separate categories. First is data integration, followed by data sources, data analysis, and then our dashboard. Starting with the integration stage, we first noticed that with the data they were providing over to us, that there were structural issues with it, and oh, okay. Is it better? Okay. the JSON data was too complex and difficult to make much use of it with our SQL tables. So what we would recommend for them to do is to collaborate closely with their vendors when it comes to the data they receive from them, so that treat it a la contract, so that it's better structured and prepared when it's delivered over to them. Moving on to our data sources, as Oski mentioned earlier, with the 98% attendance accuracy, that the model is a little too reliant on attendance when it comes to sales, and that to improve upon that, for them to capture more insights outside of attendance, that can better improve upon them, so that it isn't as simplistic as more attendance equals more sales. Moving on to the data analysis, we were able to deliver on this aspect with the code we were able to generate for them. And what we want for them to do is to take what we've done so far with that and basically integrate it and build upon that, because with that they could support and do better with their models and their dashboards. And lastly, with the Power BI dashboard, we were able to generate interactive visuals that support their ongoing data-driven decision-making. And what we would like for them to do is to incorporate the dashboard as a great resource for them, and to use it as a baseline for promotional analysis in general. And with that, any questions? Nothing? Cool. Thank you guys.
Thank you very much. Great job. Next, we have Project Team 7.
Hello? Oh, yes, it's working. Hi, everyone. This is Team 7, and our client was the University of Washington School of Medicine. Next. So these are some of my teammates. My name is Lavina. We have Jem over there, Birgul, Fiona, and Ratana. Now, the University of Washington School of Medicine, they came to us with some student data, and what they were looking for was that if we can use that particular student data in order for us to predict the students that are at risk of failing a major exam. Now, we categorized the problem that they came to us into 4 main problems. Number 1 is that students who are currently taking those exams, sometimes they get flagged when it's too late, so this could be just before a major exam. Another thing is that the faculty and the advisors have very limited tools when it comes to flagging and identifying those students who need academic intervention. Another thing was that using a one-size-fits-all approach has proved to be very challenging, because sometimes you end up providing academic intervention to students who really don't need that help, or the ones that need the help ended up being missed. So these are some of the tools and technologies that we used in order to help us solve some of these problems. And then we categorized our solution into 3 main phases. The first step was that we used machine learning, such as random forest and XGBoost, in order to build a predictive algorithm. So once we were happy with that, we were able to identify the students who are at risk of failing and the ones who are not at risk of failing. And one of my colleagues here is going to be showing you that in a little while. The second step is that we translated those findings into a real-time dashboard, and any stakeholder, anybody who is able to look at that dashboard can pretty much know whether a student is at risk or not at risk. And then the third step is that we developed some recommendations on what to do with the students who are at risk of failing. Next. So the journey was divided into 5 main phases. First step, we got the data, we cleaned the data. Second step, we did some feature engineering, whereby we were trying to find what are the columns or features that are most strongest predictors of the students that need this intervention. Third step, we built our model. Fourth step, we built the prediction, and then finally, we put everything in the dashboard. Now, along the way, we did face some challenges. One of them is the data gaps. Because the University of Washington School of Medicine gave us data that was traced back to 2011. So because of a curriculum change and effects of COVID, we ended up realizing that some of the students really did not have some major exams that we're trying to use to predict whether they would fail or pass this particular major exam. So that was the biggest challenge that we faced. So we have over 1,200 students, but we really couldn't use that data because of that. And this brings us to the second challenge that we faced, which was a single cohort limitation, because what we're trying to do is just build a pilot project, and so we only ended up using very little data of over like 400 students because we just wanted to prove to them if this can actually work. So we only ended up working with data for the most recent academic years. And then the third challenge that we faced is that some of the recommendations we've given them, obviously they haven't tested them yet on the current students, so we're not really sure in terms of that particular area. So I'll hand over to my colleague to do the demo right now.
Thank you, Lavina. This is Jem. So I will walk you through our early intervention dashboard. So this dashboard built in Power BI for UW School of Medicine to identify students at risk who are academically at risk. So we have designed this dashboard with clarity and speed in mind. We have followed the 5-second rule of dashboard, like creating a dashboard to give users, like users can get immediately the grasp of core insight, like how many students at risk versus safe. At the right, we have risk distribution, which can give us an instant breakdown of student groups. Also, for deeper filtering, we have 2 main tools. On the left side, we have risk group slicer, which we can toggle between at risk and safe, and this updates all the related visuals dynamically. As a second, we have confidence level slider, which we can adjust, like user can adjust the model's confidence level based on the how certain the model is on prediction. So if you scroll up like this, right now it's between 74 and 100% confidence score, which gives us 53 at risk, 317 safe students. On the bottom left, we have student IDs, which we can scroll or toggle. And upon selecting one, we get 2 insights. First one is average block score, and the second one is individual risk score confidence. So this can allow faculty or advisors to interact or like get the insights quickly. So they can give or they can support the students who are at risk immediately. We also applied clear tooltips and also accessible colors for users to engage with the dashboard effectively. In short, this dashboard is not just like numbers, this is an early actionable warning system. And next, I will go ahead and leave it to Lavina for the recommendations.
All right, Jem, thank you for that. So for our recommendations, first thing is that we are trying to find a way for the University of Washington School of Medicine to integrate this into their current curriculum. As you saw earlier, we had like some student IDs, but those are not actual student IDs. They are masked, obviously, for privacy concerns. So they'll have to integrate with whatever they are using so that any academic faculty or advisor can pretty much look up a student and know that this is a student that is at risk of failing or not. The other recommendation is just expanding that data set. I did mention we did have some data gaps in terms of previous years and the whole curriculum change. So definitely expanding that beyond our pilot project. And then the third one is just to track some of the recommendations that we've given them on whether they actually work or not. Yeah, so thank you. That was team 7. Yeah. Any questions?
Any questions from the audience? All right, I have a question. Can we go back to the dashboard? Could we go to the interactive portion? Great. I think this is great. It looks it makes sense and it's very straightforward. And I think you said the 5-second rule definitely applies here. It was very easy to interpret, very clear, and I also think, therefore, very impactful. I just had a question when you're talking about the confidence level. Is that adjusting the cutoff? Like the cutoff value for the classification? Because this is a classification model, right? So is that like a slider for the cutoff value?
Oh, actually, it's, I think it was the previous class where we explained, for example, if I clicked on this student, 4095, I am 96% confident that this student is actually safe. So 31 was the lowest one, 100 was the highest. So our client came back to us and told us that since the data set was very small, whereby we had about 400 students, if we were able to just do the slider and just... Yeah, so she said that we can just have that particular range. For example, if they just want to focus on the students who we are 80% confident are at risk or not at risk, we just have sort of like a filtration for them, if that answers your question. So that was just the range that we recommended based on the algorithm.
Okay, great. So your your dependent variable is this confidence level. Yeah. Is that correct? Okay, excellent. So when you filter, so essentially that's a filter, so it will highlight the students that fall within that range, yes. the predicted values that fall within that range.
Yes, yes. So it's in between.
Excellent.
Yeah, so like this one is 95% confident, they're safe. Some are like 60, so maybe they're like, maybe we shouldn't focus on that. Again, depend on the resource allocation. So they can be like, maybe we'll focus on students who are 80% at risk so that we can maybe not focus on these ones that are 40% at risk, because we're not really sure.
That's great. And I think this is a tool that could be useful outside of just the School of Medicine. I mean, for anyone that wants to evaluate or try to get a snapshot view or an idea of the health in terms of academic progress, I think this could be very beneficial for that. So I think you've created a solution that I think, even though that School of Medicine is a prototype, that I think other schools could use. So excellent.
Thank you so much.
I was just gonna ask, do you guys know the dropout rates or like every year for the at-risk students and stuff?
Interesting. No, they haven't told us yet.
Okay.
Yeah, why is that?
Huh?
Why would you think it's important to know? Maybe we can use it for like a recommendation. Mm-hmm.
Well, I was just wondering, because the at-risk students, do some of them drop out like every year or every graduating class?
Oh, that's interesting, actually. Yeah, it's definitely a factor that we can bring up, because maybe there are students who they end up performing poorly and then they were not detected early on. So definitely a nice insight to include in our analysis. Thank you.
Yeah. Thanks.
Any other questions? All right, excellent. Thank you very much. Okay, and project team 8.
Hello, everyone. We are Project Team 8, and we worked with the University of Washington Institutional Research and the Teaching and Learning Center, as we will get into here in a second. So our initial prompt from the Institutional Research Department was to take a general look at student data and try to identify trends that may help to predict dropout rate or analyze things along those lines. There had been a trend of increasing dropout rate. However, last year there was an increase in this, which is a promising sign as well. And we were offered the opportunity to work with the Teaching and Learning Center. We got a data set from them. And this is the first time that a MSBA group has gotten to interact with this organization. So we were very excited to see how that data could lead to broader implications for student retention. So in looking at the data, as the previous group very well demonstrated, student data is a very thorny thing to work with. It's hard to find a label to predict. It's hard to generalize cohort to cohort. What is a baseline student? All of these things are complicated. So we initially took the approach of unsupervised learning without a label to predict. We kind of just wanted to take a general overview of, are there patterns within this data set that could help us move forward with actual insights? And I will let Munisha talk through the project phases.
Thank you, Billy. Hi, everyone. It's me, Manisha. So I'm going to quickly talk about the phases that we have made on this collaborative project with the TLC team. Taking a quick recap at our phase 1, we were given a very wide spectrum of ideas, like how to address the scope of our project, which is like to address the retention and the enrollment issues that the university is facing. We quickly shifted our focus towards the TLC as our client Andrew helped us to navigate like the on-campus resources can help to affect the student success. So for the first phase, we just decided to explore the TLC dataset and the environment that we could use further. Reaching up to the phase 2, we got to explore the dataset and the database server. The problem that we got with the dataset is that the data that the students enter is like whatever they enter, it get like validated easily, even if they like enter the random information, so that it get validated, which makes it like very difficult to track the actual student data, and then it makes us like difficult to predict something out of it. So we decided to work on it, and then we got some data set from Andrew as well, and with the TLC team too, which helps us to develop some visualization with kind of potential visualization that we could make out of it, and to show that if we got the actual data set or the right data sets, then it is like what it should be. So so we decided to create a realistic sign-up form, which is supposed to be very like a simple and familiar, and that will help to track the actual student data. So now I'll hand over to Bernie to talk more about this solution.
Hi guys, I'm Bernie, and I will be talking about the proposed solution that we created. So yeah, we created a checkout form. So essentially, if someone visits the TLC and they're on their way out, they will sign this form. Rodrigo will talk more about it in a little bit. But these are the main characteristics of the form, because the current TLC form right now, it doesn't have a lot of restrictions, so there's a lot of data entry error because of that. So for example, a student ID number should be 7 digits. And so our new form, it makes sure it corrects all of that. So if someone enters a student number that's longer or shorter, it will like flag, and basically you're not able to submit the form. So it has a lot of restrictions that makes the data entry more accurate. And so here are some of the benefits that the form will provide. Engagement with academic support. So if a student is if the student usually visits the TLC, it tells that the student's seeking help, and it helps as far as like retention efforts go. If we track the students' GPA and correlate that with their TLC visits, we can see that, okay, the student's doing very well. Course difficulty and struggles. So if someone's frequently visiting the TLC for a particular course or subject, we can track to see that, okay, yeah, they need help in this field. Also, utilization of institutional resources. So as far as the university investing in the TLC or providing more funding to the TLC, the data from our form can help with that. Also, student behavior patterns. So if someone is signing in around, like, let's say dead week or finals week, we know that a lot of students usually wait till the last minute. So perhaps the TLC could, send out early reminders during the quarter. That way, everyone is not like cramming to dead week or finals week. And also it could help with staffing and stuff. So if TLC, like the tutors at the TLC, perhaps they could be more staffed, during busy hours or busy weeks, like the dead week and finals week. And then also equity and access insights. Right now, I think the psychology majors, they visit the TLC the most. So we have other majors that don't. So perhaps the data from the form could help. For example, like the nursing school, just send out reminders like, hey, the TLC is there for you guys to use. So just make sure all the students have equal access to the TLC and are using the resources. Thank you. So now Rodrigo will talk about the characteristics of the form that we created. Thank you.
Thank you, Bernie. Hello, everyone. My name is Rodrigo Martinez. I'm excited to be here. So this is the form. As Bernie mentioned, there's so many benefits that this form can bring to the TLC, but as well to the school. As we know, the TLC is a school resource, and we want decision makers to know that the TLC is making an impact, and what they're doing, it's good for the students and for the school. So one of the options is to have a IRQ code that students can scan and essentially use their phones. But the issue is that some students will leave it unattended or, kind of just scan it. And that's what I have done in the past. Just scan a code and leave it there and just forget it. So there's many options that the TLC can bring in, such as maybe a console or using maybe a poster on the top. And I'll show you how this form works in a little bit. We know that the TLC does have different entrances, and so there is no one entrance where they can catch students coming in. So in essence, the idea is to show and maybe bring in a big old poster saying, hey, scan here on your way in or you went out. We did mention that this form is a checkout form, but it's up to the TLC to, kind of figure out what works best for them. So the idea is that, let's go ahead. Having this form filled out correctly will bring something like this to the TLC. This is a dashboard that we created in Power BI, and it's off of the information that we gathered. Most of it, it's actually synthetic. We based it off on the metrics from the school website, based on the years. And as you can see, the TLC will be able to bring in information such as student count based on their major, student count, based on different metrics that they can take advantage of. To your right, or actually my right, your left, you can see the metrics. We used Qualtrics for this form. Andrew Chamberlain actually advised we use this because it integrates really well with their database. And let's go ahead and show you the preview of this form. Okay, so on your left again, it shows you the way it'll look on the phone. And so the validation is very important because sometimes students will want to come in and type their IDs, or maybe they don't know their IDs. How many know their IDs here off the top of your head? Oh, we have a few actually. Oh, I'm surprised. Okay, awesome. I don't even know mine. So this form took me 30 seconds to fill out, and it's really basic on purpose so that students can just go in and go out. By the time it takes to get the ID out, it'll probably take half of the time that it takes me to fill out this form. But as you can see, I'm just going to do random numbers or something random. And so it'll show you right away that it doesn't work. I did bring a scanner, and it's one of the items that we'll recommend the TLC to use. It's a basic scanner. It's about $20 on Amazon. It's just a plug and play. So I'll just come in, get my ID, and there's some code that, you know, the TLC along with IT will have to come in, and because there are prefixes and suffixes attached to the card that you have to get rid of, so you can actually see the IDs. This is not my actual ID, by the way. So stop writing my ID over there. No, okay. So as you can see, the scan was seven items, so it did allow me to go forward and basic questions so that students don't have to be, you know, filling things out. So is this your first time? If it is, it'll take them to one form. If it's not the first time, it'll take them to another form. For the purpose of this demonstration, I left both on there. But one thing they will have to type in is their net ID. We noticed that some of this information recycles throughout the years. So if we have the net ID attached to the ID, we're able to track students better this way, right? So that one I'll have to review. Okay, and so am I dropping dropping in, or do I have an appointment? And another important thing is a drop-down list. I don't know my class name. I don't know what number, or, you know, I just know it's math, some kind of math, or analytics. So I'm just gonna type in something in here, and then this list pops up. And that way, oh, yes, I remember, it's the, it was actually social media, it wasn't math. You know, so there it is, and that way the information for the analytics will stay consistent. That way we know exactly what course they came in for, and here they're free to type in, you know, okay, and then it's asking, how long did it take you? Since we are considering to be a checkout form, we want to know how long it took them for their visit. And in, you know, like really general, was it a good visit or not? You know, okay, yeah, you know what? It was good. I was hungry, so I'll just put a 4. And so, and then it's all set. You know, it did take me a while to, you know, kind of fill it out here. But as you can see, it should take them no more than 30 seconds. And with this information, we know what class they came in for. We know if they do want to provide information on what they're having trouble with, how long it took them, when. Obviously, we're going to track date, time, so that we know how many times that student is coming in, if they're coming in at the late of the semester, if they're coming in the beginning. So we know if it's something that, you know, last minute thing, or are they being consistent with what they're looking into. And that's the application. Now, we are considering some assumptions, and for that, Alex is going to cover those. Thank you.
I'll just continue like this. My name's Alex, and so as we look forward, keeping the future in mind with the TLC, we continue to assume that the TLC will continue to be a resource offered to students on campus, and that students will utilize the TLC. Our concerns, as Rodrigo mentioned, is there are 3 entrances to the TLC, so that there's active engagement with that form. And so our potential issues is that maybe we're not capturing every visit, but what we do believe is that with this form is that the visits that we do capture, the data is accurate. It's it's current. And so this provides opportunities for the TLC to develop those visualizations, those metrics of the TLC usage to show that this is a resource that students value, that students utilize, and potentially there is no baseline student, but you can also incorporate just for analytical purpose for fun, the aspects of how it impacts grades. And so concluding with that, I would like to thank our project sponsor, Joe Lawless, the UWT Institutional Research Center, specifically Andrew Chamberlain and Alice Few, and also the Teaching and Learning Center, Cara Hale and Dwayne Chambers. I believe he's with us today. And then also the Center for Business Analytics team, Michael Turk and Ozge. And with that, we'll leave the floor open for any questions.
Any questions for the team? I'd like to say a couple things. This is great. You know, we've had the opportunity to have student teams work with the University of Washington Tacoma Department of Institutional Research for some years now. And when I heard this project team present midway through the year that they were going to be also collaborating with the TLC, I was extremely excited by this, and it made me realize, because, I mean, retention is so important, right, for so many reasons. My first thought was, why haven't we been doing this all along? So I'm so glad you had the opportunity, the idea came up, you had the opportunity to dig into this and present these results to the university. I think it's going to be extremely helpful. I'm excited for the collaboration opportunities ahead to continue in working with the Department of Institutional Research with this emphasis on the TLC. I think it's fantastic. Can we go back to something, the very first page in your demo? I also want to point something else out. Okay, can you enter 3 digits for that student ID again? Okay, that little red message, this may look like a small thing, but it cannot be overstated how beneficial user-defined constraints like this can be, okay? Let me ask everyone here, when you first obtained your client's data, how many of you received data that was perfectly clean in all columns? I almost saw, and I was gonna call that out. Okay, great. By the way, for those that can't see the audience, there were no hands raised. How many would say that data preparation was the largest time expenditure in your applied project in working with the data? Okay, a lot of hands, I would say. Something like this can be such a time saver because it avoids all of that data preparation step. Again, it looks like a small thing in the demo, but it can be so helpful and such a time saver over time. Think about data that's populated and incorporated. If we have hundreds of thousands of records that are populated potentially incorrectly, that just expands about, you know, in terms of the amount of time digging that you have to do for the data preparation. So excellent work on that.
I'll also jump in real quick and explain something that I think that we elided over because we're a little bit familiar with our project at this point. The main thing that we're trying to achieve by using a student ID or net ID to connect student data is that in the university's data warehouse, which institutional research has access to, but up to this point TLC hasn't had access to, if you can connect those two things to the system key, you have all of the students' information. So part of the reason that the engagement with the TLC form has been a little bit inconsistent is because they're trying to get a lot of demographic data from their students. They want to know why students are using the TLC, they want to know who those students are. The faster we can make this form, and the more reliably we can connect this information back to the university's data warehouse, they have all of that information with 2 inputs from students instead of 14 inputs from students. And that will make it easier to take that data, count the number of times that this form is submitted for visit counts, any kind of sentiment analysis that they want to try and add on to this. It's a very flexible form, and when we presented this to them last week, there were tons of ideas of like, oh, we could change it to do this to make it easier, and the flexibility is the point, because if the form isn't engaged with, then there's not a whole lot of reason for it to exist. But the easier it is for students to engage with this form, the easier it is to connect that information back to the data warehouse, the easier it is to have arguably more information than they had previously, as well as a better picture of who's using the TLC potentially why, and then trying to find patterns in that data to make recommendations going forward.
Great. Any other questions or? Yeah, here. Thanks.
Is there not a way to require the NetID sign-in before filling out the form?
There probably is. We didn't specifically talk to the IT department, and a lot of the ideas that we had of like, oh, the form could be this, because there are also like NFC readers all over campus where you scan your ID to get into buildings. Is there a way to use one of those to scan as you're walking into or out of the TLC? Because as we mentioned, there are like 5 entrances. Students use it in a variety of ways. Even a 30-second form on the way out can be a little bit tricky because Dwayne gave us the example of last week. There were students there who were trying to prepare for a test who were going to be slightly late to the test because of when they were in the TLC. So sometimes there's a time constraint there, but I'm sure that there are options for that kind of a thing, but it will likely involve bringing in the IT department to kind of get to the back end of those.
And also to add on that, on the TLC site, if you've never interacted with it, out of curiosity, I did this quarter and in previous quarters just to see what my account said. And so it does have that a single sign-on with the NetID into the TLC because there is an online scheduling option for your appointments depending on, I believe if it's like a writing consultation on a paper that you have or just an online scheduling. But when I went into my profile, I can change my student ID to whatever I wanted it to be. I could have even changed, I think it still said I was a junior. And so I can change that field also. And so I believe this form helps bridge those inconsistencies and bring in that validation, yeah.
And then do you guys already, or have you guys looked at the information that they already get from the appointments that are made? Because they would get data from that too, from creating an appointment. And then is there any chance of any duplicated data from collecting that same drop-in information from this form? Or are they gonna be completely separate?
I don't have a great idea of exactly how this will be implemented because I think it's going to be kind of a moving target. They may choose to use one or the other going forward, but some of the data from that online check-in form is what was provided to us in our initial data set. And what's kind of tricky about that is that it's relatively static. It doesn't update very frequently. As Alex said, it's possible to say you're a junior, but you're a master's student. All of those kinds of things become a little bit odd. So my suggestion would probably be to try running with, like, see how far you can get with just this. The simpler you make it, the more likely it is that people actually interact with it, the more likely it is that you get usable data from it. However, it's always a moving target. It depends on how students are interacting with it and what's actually working. So there are definitely options, but it'll be fun for them to kind of experiment with going forward, I'm sure.
Thank you.
And in addition to that, there is a way to integrate the form to online information and whatever we're collecting with this form as well. That way we can avoid any duplicates and bring in all the analytics so that we know what's going on with online and what's going on with in-person.
And furthermore, please don't confound the data set by signing on into the TLC as Rodrigo, that you have a student ID. Anything else? All right, excellent. Thank you very much. All right, with that, we'll go ahead and take another break. It's approximately, I'd say it's just before 11 o'clock. We'll go ahead and resume at 11:10. Thank you. All right, everyone, we'll go ahead and resume. Test, test, test. I'll say one thing real quick. Okay, everyone, there is one thing for those that are here in the room and also for those that are online. If you look on our website, there is, we do have somewhat of a competition element for best project. So there is a button on the left side of our website where you can vote and select which project you feel is the best project, and that project team will be recognized for that. So the vote for that is going to be open until next Wednesday, June 4th. So for those that are potentially viewing this as a recording, you'll have the opportunity to vote up until that time. So I would like to go ahead and now we'll proceed, introduce Team 9.
Hello, everyone. Thank you for being here today. We partnered with Virginia Mason Franciscan Health for their procedure card cost reduction. We are Team 9. My name is Joe, and this is Alex, Anaga, and Atisha. So about our project, Virginia Mason is local healthcare provider, and they have about 18,000 employees across 10 campuses. And they're estimated to do about 60,000 surgeries a year, and the supplies that they use are around 250,000 different supplies. For the project overview, our goal was to develop a process to identify cost-saving processes and saving opportunities. And how we're going to do that is by creating a methodology for identifying cost variations between procedures, surgeons, and locations. And throughout the year, we divided this into 4 different phases. Phase 1 was to discover and plan. Phase 2 was the data analysis and design approach. Phase 3 was the analysis and development. And phase 4 is the deployment to Virginia Mason.
Thanks, Joe. Now that we have the introduction part sorted, let's answer the question, what is a procedure card? So procedure card lists all the supplies, equipments, and instruments a surgeon needs for a surgery. However, variation in these cards may lead to cost inefficiency, excess inventory, and supply waste. Now, for the data part of the project, we worked with real surgical data that was shared by the client, a pick list database or an access database, that was the order sheet that contained all the supplies, inventory, records related to specific surgery events. The other one was the Lawson or an Excel data set, the return sheet that contained list of unused supplies that needs to be restocked after the surgery was completed. For our analysis plan, our objective was to understand the cost drivers and identify cost-saving opportunities. We used tools like Power BI, RStudio, Excel for our analysis. And our analytical techniques was done in 4 steps: descriptive, diagnostic, predictive, and prescriptive analysis. Our key variables included surgeon, procedure, location, and departments, with outcomes like total surgery, total cost, supply usage, and return rates. For the demo part of the presentation, let me quickly walk you through the dashboards that we made. The dashboard that we made to answer the question, which surgeon cost Virginia Mason the most and why? At the top, we can see the big picture, that is like over $56 million in total surgical cost, with approximately 508,000 of waste across 22,000 surgeries, and gives us an average of $52 per surgery. On the left here, we can see that this bar chart ranks the surgeons by their total cost. So we can see that the surgeon cost approximately $3.26 million to Virginia Mason. Next, on the right, we have a bar chart for used versus waste surgical cost per surgeon. The blue bars shows what was used when the surgery was done, and the red bar shows the wasted supplies, like the supplies that were picked but later on were returned. We also included a table that drills down into surgeons' total cases, their average surgery, and what was the waste per surgeon. We also have a trend line that shows surgical volume changes over month to month. As we can see that there is this spike in October 2024, that could be possibly due to seasonality or scheduling shifts. And finally, our bubble chart, it compares total cost versus surgeries as we can see, showing that some high-performing surgeons perform fewer surgeries that could be show us that pointing to the areas for cost optimization.
Thank you, Adisha. Good morning, everyone. I'm Anaga Parki. I'll be presenting descriptive analysis for Virginia Mason Franciscan Health. Okay, it is not going up. Okay, so Virginia Mason gave us data for a duration of 6 months. This dashboard shows 6 months of data. Virginia Mason operates at 10 locations and 403 surgeons and 868 primary procedures. The bar chart below this showing procedure count with the line chart showing total monthly spent on the surgeries. As we can see, in the month of October, the cost for the surgery was significantly higher, followed by a drop in the month of November and then December. The next, to identify now which top 5 surgeons and top 5 procedures costing us total higher cost, we develop a bar chart where it is shown. Later, to dig into analysis, monthly analysis, we develop a tabular chart to deep dive in monthly total cost on the procedures. Moving on to the next predictive analysis. After our analysis performed, we developed this dashboard. With that, we are predicting the cost for total surgery will go significantly higher in the next few months. As we can see, the total cost was 55.87 million, and the total return is 2.4 million. This return is the surgical supply cost, which are initially thought to be used, but now it is a return. These are the physical items which need to be returned in the storeroom on the shelf by a human. So we need to identify the cost associated with the item cost to return on the shelf. For that, we develop a model. If the item cost to return is higher than the actual cost, then it's a no return. Otherwise, it's a clear return. With this analysis, we developed two visuals. One is a tabular form, where we are showing the procedures which have a higher cost in return of the items. And this bar chart shows top 5 procedure which has a higher return surgical cost to identify and maintain inventory while picking up the surgery cost. With this, I conclude my analysis. Thank you.
All right. So once the data sources were summarized to a per case level, we were able to test linear and nonlinear models in RStudio. We had the best results with XGBoost. So as a reminder, R squared is the proportion of variation of the dependent variable that's predictable from the independent variable. So higher is always better. So here's the results of the rounds of testing we did with the best performing model called XGBoost. We stayed conservative with our parameters and improved the MAE and R squared with each time. So our predicted values for surgery are the cost to restock, the total cost of the surgery case, the quantity of items used, and value of supplies used and returned. So here we can look at what happens when we input existing surgery case attribute information and run the model. So there's 2 randomly chosen cases there, and we can see how closely the predictions match the historical data.
For the concerns and assumptions, our team does not possess the specific medical knowledge for preventing independent recommendations towards the surgical resources or the card preferences. So our recommendation is to utilize our tools towards an internal way to identify cost procedures and track supply usage trends. And in conclusion, our analysis creates a quick, valuable insight into the use of surgical supplies. Our predictive model can help forecast supply usage and allow opportunities for budget efficiency. Thank you again for being here. And are there any questions?
Any questions for the team? All right, I'll go. Can we go back to the dashboard, please?
Which one?
The predictive, I believe. Thank you. Yeah, great. Okay. So while this is monitoring the current state, what, you know, in understanding, in relating the ideal, the goal of the project and what, you know, the metrics are showing here, in an ideal situation, what would these metrics look like for total cost, total used, and total return? Like, as they're monitoring this, what are they trying to, which of these metrics would they be trying to maximize, minimize, et cetera? Can you use the, thank you, use the microphone?
It would be the total return, because our objective was to lower the cost of the procedure card in general.
Got
so
it.
the total return is kind of an unnecessary step that gets added because like surgeon sometimes order extra stuff to for the surgery to be on a safer side, because they cannot afford to run out of the OR and then get the stuff. So the total return is the main. It's the other.
Oh, I was showing waste cost per surgeon.
Yeah, so that is like our main key point was to minimize the return so that they can monitor it and maybe track or keep an eye on the stuff that was returned frequently so that they can minimize it and lower the cost that was, because when the stuff is returned, there is a
Can you do the mic?
Sorry. Whenever the surgical instruments are returned, there is a person in the stock room that by hand, like they need to keep it back. So
Okay.
there is this work hour that is added to the cost. So that is used to monitor, like if they can lower that at their end, it would really help.
Okay, got it. So the total return will have additional operational costs associated with it. Okay, so they're trying to minimize that. And then I assume if they're able to dial that in order to minimize that, their upfront, their procurement costs would also be lower, correct?
Correct.
Okay. This is really, this is a really interesting one. There's so many moving parts in terms of how this flows throughout the business process. Yeah.
Thank you.
Yeah. Any follow-up questions? Awesome. Thank you very much.
Thank you.
Great job. And we have Project Team 10. Yeah. Make sure it's turned on here. Turn it on. Yes, it's on. You can always test it too.
Test.
Yeah, no worries.
All right, hello everyone. Thank you for coming. We're going to be presenting another Virginia Mason Franciscan Health applied project for the MSBA program 2025. And our project is revolving around diagnostic imaging referrals. We are going to be referring to Virginia Mason Franciscan Health as VMFH during the presentation. So this is our team, Team 10. We have Dia, Mimi, Marie, Ashvarya, and Khan, and myself, Chase. Our client representative is Caitlin Schultz, the program manager of Physician Enterprise Operations. We also had Karen Phipps, who did the majority of our data engineering. And we had oversight from Deepak Devastali, the president of St. Anne Hospital. We also want to do a special shout out to Michael Turek, Ozge, and Lindsay, who have helped us throughout this the last 12 months. So we're going to briefly go through the executive summary, our progress through this project, a demo of the dashboard and our findings, our recommendations moving forward, and then Q&A. So the business problem is that VMFH were losing a significant amount of revenue due to their imaging services going to clinics outside of their internal network. This is known as outmigration. We found an opportunity for more visibility to this information via looking at referral patterns, looking at clinics or care providers where these anomalies are occurring. And we also saw an opportunity moving forward from this project for flagging referrals that potentially have a higher statistical risk so that VMFH can allocate more resources towards these specific imaging referrals. So the initial challenge is that VMFH didn't have a central workspace to review and analyze this information. It was a complex collaboration between multiple data sources to be able to put this all into a centralized dashboard and help management to use that information. I'm going to go ahead and pass it off to Dia for the goal and scope.
Yep, thank you, Chase. I think it's audible, yeah. So now moving on to the goal and scope, the primary goal of our project is to build a reporting dashboard that summarizes the imaging referrals that are going outside the VMFH network. So by doing so, our aim is to analyze these referral trends and pinpoint the areas that have high opportunities where VMFH can make infrastructural improvements to retain more networks retain more referrals in network. So this will ultimately improve decision making and also reduce revenue leakage. So now moving on to the objectives here. So VMFH team was looking for both a high level and detailed view of imaging referral trends. This means that they wanted a dashboard that shows patterns like trends over time and by region, and also it provides the ability to drill down into specifics like the procedure type and the exact location where the referrals are going. So with this insight, the leadership can make decisions like to improve the network integrity and also reduce the volume of referrals that are going outside the VMFH network. Now, moving on to the progress of our project, as you can see, we followed a clear plan over the past year to complete this project. So we started in the summer with the project charter where we outlined the project goals, scope, and deliverables. We also did a thorough company and industry analysis to better understand where VMFH stood in the healthcare ecosystem. So based on that, we developed a scope management plan where we outlined the project deliverables, the project boundaries, and set realistic expectations. And coming to the fall quarter, we finalized our scope management plan, and we gathered the necessary data we needed to analyze our referral trends. And also then we collected the necessary data about that, and we built the dashboard, the basic fundamental building blocks needed for the dashboard. And coming to the winter quarter, we finalized the dashboard, and we built a predictive model to see what might happen in the future. And in the current, that is the spring quarter, we finalized our dashboard again based on the stakeholders' decision, and then we showed how the predictive model can help in the long run. And we also made a roadmap that shows future improvements, and we shared our key findings and recommendations, and then we wrapped up our project with a full client handoff. Now, I would like to hand over to Mimi to show us the demo.
Hi everyone, my name is Mimi. I'm going to walk you through the dashboard that we've been working with our client for the past 1 year. Oh. All right. Okay. So this is the high-level overview dashboard that we have built with the client. It includes 3 main metrics right here. The very first one is the total number of medical imaging referrals, and then how many of those are outmigrated, and what is the percentage of them are outmigration. And basically, the lower these numbers are, the better. Besides that, we also contain the breakdown of the outmigration in volume and the percentage against the total number of referrals based on the following 4 main variables: region, order class, period, and specialty. Besides the straightforward visualizations and the dynamic filtering system, we also provide our client with a tip box right here to increase our user engagement. Besides that, we also add on a function that our clients really appreciate. It's called drill through. And this function allows our clients to trace in detail the key drivers of that cause the outmigration. So let's have a look at one of the example. Oh, I forgot to mention, the data that we're showing right here are all anonymized and dummy data to ensure our clients' information confidentiality. So let's have a look at the drill through. So with this drill through, our clients would be able to view more in details the visualizations of the key drivers that cause the outmigration. And if they want to deep dive more for further investigation, they can expand this table right here to see the key drivers. And at the end right here, they can view the referral ID. And this ID, they can go into Epic, which is a system that they use to further investigate the reason why of the outmigration. Another dashboard that our clients really appreciate is this decomposition tree. And this tree will allow them to see the further breakdown of where the outmigration went. And they can use this dashboard right here to do a gap analysis. So let's go back to the recommendation. So with the dashboard demo, here would be our recommendations for our clients. First of all is to integrate the usage of the dashboard to their daily workflow. This is a good way for them to identify any areas of improvement. Second is to investigate any procedure shortfall by collaborating with any of the relevant departments to identify referral patterns, investigate and document any reasons of the out-of-network referrals, and also highlight any opportunity for them to keep the referrals in network. Third is to standardize the referral process by eliminating any of the discrepancies implemented by their referral coordinators. And last but not least, even though this is not their main focus for this project that we're working with them the past 1 year, but we highly encourage them to explore the power of predictive modeling as a way to detect any outmigration risk in the future. And that concludes our presentation for today. Feel free to let us know if you have any question, and thank you for listening.
Any questions from the audience? How how many different services approximately would fall within that imaging services category? Do we know?
Hundreds.
Oh, really?
Yeah.
Wow. And is the landscape pretty competitive for those? I mean, are there many alternative places that offer a wide range of those services or a small range? What does that look like?
Yeah, so there are several other clinics in the area that offer many of them. I would say that it kind of depends on insurance. So if you have an insurance plan that you'd have to look at those details a little bit more as far as where they would refer you. If the person is not booked immediately through VMFH, there's a higher chance that they'll be booked elsewhere.
And thank you. And to add on, sometimes about the location as well. There's certain modality that VMFH has not had at the moment, so that's why they have to be out-migrated. And another thing is VMFH is currently also do joint venture with some of the other clinics as well. So,
yeah. Great, thank you. Have there been any discussions from your client about how they plan to operationalize this data yet? Or will they just be pending and waiting on your recommendations?
So now they want to see the dashboard, like the clinical managers, they just want to see how the referrals are going or where they're going so that they can find what is happening inside the system.
Got it.
Exactly, that is what they're trying to do. And yeah, we showed our recommendations. Hopefully they'll take that into account. Yeah, thank you.
Great.
I think they've already begun using it to a limited capacity.
Excellent.
Yeah, to add on to that, one of the recommendations about the predictive modeling was that once we know what will happen in the future, and then if we take proactive steps to, reduce the referrals that are going outside, it will eventually impact the revenue. So that is one of the key steps that we would like to recommend to them.
Great. Anything else? All right, thank you very much.
Thank you.
All right, coming ahead, we have our final presentation for the morning, Project Team 11.
Do you know if that mic on the left works?
It does, yeah, and you can, it's even flexible. Great.
All right, good morning, everyone. We're Project Team 11 with the Washington Interscholastic Activities Association, the WIAA. We were doing a streaming impact on live in-person attendance. This is our consulting team here. We got myself, I'm Thomas. We got Francisco, Jan, Joanne, and Franco, and our project team members with the WIAA, Meg Kaufman and Sean Bissett. Just to be background, the WIAA was founded in 1905, and they run a lot of, what they do is they hold event management for state tournaments for like high school athletics and sports teams. Recently, they started making a partnership deal with the National Federation of High School Sports Network to stream all of their events. And so that's what kind of brought about the question of this here is that if they start streaming their events, how is that going to affect their live in-person attendance? And since 53% of their revenue comes from that in-person attendance and ticket sales, this was going to, there's a worry that there might be a major impact on their biggest revenue source. So through our project, we had our 4 phases. Phase 1, the business problem and discovery. Phase 2, our data collection and cleaning. Phase 3 being our analysis and predictive analysis. Phase 4, our final dashboard and deliverable. I'll be briefly discussing what we did in each of those phases. Phase 1 was just learning more about the business and the business discovery, industry, and market analysis, and this is where we learned a bit about the WIAA and their partnership with the NFHS network, as well as GoFan that helped to run and manage their ticket sales. In Phase 2, we began our data collection and cleaning. We got 3 years of ticketing sales data and 2 years of streaming data. That came to us in the form of Excel spreadsheets, and we used that in R to clean the data. Taking away duplicates, filling in null values where appropriate, as well as standardizing date formats and event and sport name types. In phase 3, we started running our predictive analysis, and we have 2 examples of that here. The one on the left is our ticket sales, and on the right we have our streaming views. With the ticket sales there, we have the line pointing to when streaming was introduced, and you can see on that where we have these peaks and valleys there. It drops down when there are no events. There's obviously no ticket sales or streaming views on either one of them. But where we look at the peaks of those, where the events are actually selling, we can see them slowly but gradually continuously increasing. And as we do our predictive analysis there, we can see that trend is predicted to continue on through 2025. The same thing is following with the same trends through streaming. On the right graph there, you see the peaks where the events are happening. It's slowly going up year over year, and our predictions are that's going up. This gives us a little bit of insight that we're not seeing any type of negative effect on ticket sales through streaming. In phase 4, we have our final interactive dashboard that we're going to create and give over to our client, and I'm going to go ahead and hand it over to Francisco to show a little bit of a demo of that.
Hello guys, I just want to say everyone's looking spiffy. Just give me a second to set up. Good morning, everyone. As Thomas said, our dashboard was built in Power BI. We designed the dashboard around WIAA executives, staff, and stakeholders, like Sean and Mick in mind. With such a busy schedule that can involve a lot of travel across the state, they need quick, actionable insights. For right now, I'll walk you guys through 3 common use cases that the dashboard can help with. In the first scenario, let's say it's a Monday morning after a big week. Maybe there was a state tournament, or maybe we have some staff coming back from vacation. So they need a refresher about how the association is doing. By default, all the filters are on, so one click to open the dashboard and you get a complete picture across all sports. Looking over here on the left side, we have a pie chart visualization that shows users what slice of the pie each sport is taking in ticket sales. As you can see, the biggest slice takers are basketball and football, followed by a variety of other sports. Our bar chart on the right shows how ticket sales have been performing each academic year. In this case, ticket sales have been growing each academic year. You can see from red to green, so pretty good growth. And then our last visualization is a line graph. The line graph is meant to give users a clear idea of the patterns in ticket sales over time. Besides the 3 main visualizations, we have accompanying key performance indicators, or KPIs, that also give them a way to gauge performance, and some tooltips on each visualization that give specific numbers for each part. So for example, basketball has a specific number of 623,315 tickets across the past 4 academic years. Moving forward to use case 2, I'll be switching over to the viewership dashboard, and as you guys can see, it's identical. So that means once you learn how to use one dashboard, you're not going to have to learn how to use the next one. In this case, I am going to select just 2 sports, so I'm going to deselect everything and then click on baseball and softball. By selecting both sports, you can get a side-by-side comparison of the viewership split between the 2 sports. Both are showing healthy growth trends. In here, it could also show you maybe where there's some missing data or incomplete data. In this case, 24-25, we're currently in the spring season, so you see the red bar there, meaning that we don't have the data for the spring season currently. But in general, both sports have a good viewership number with hundreds of streams and a good average amount of views over the course of the academic years. The highest number of views has been 1,000, which shows there could be potential to tap more into the streaming on that side. So what this would enable is some evidence-based decision-making about program investment where resource allocation can be justified with some data to back it up. And in our last situation, I'm going to just select soccer. I like soccer. So here the pie chart won't mean as much as it does in the other ones, but let's imagine there's an athletic coordinator for a certain high school, and they need performance data for their annual review and next year's planning. Perhaps they have an idea of how soccer is performing at their school, but they want to know how it's doing across the state. This isolated view shows soccer's complete performance story across the academic years. There's a clear, healthy trajectory that shows that there's a large number of events with strong support in the average number of streams. You know, soccer isn't as popular in other countries, but still there's people tuning into the streams with an average number of 34 people per stream, and even peaking as high as 935 across 8,000 streams. So what this would do is give you an individual sports analysis in seconds that could help optimize scheduling and perhaps give some insight into marketing promotion efforts for the upcoming season. And just to summarize, both dashboards, they offer quick solutions to shared challenges. The identical layout between both dashboards means that whatever team or user is using it, they only need to learn it once. And whether it's coming back to the office, allocating resources, or preparing for a future season, the dashboard transforms what can be tedious data analysis across several different spreadsheets in different locations from different vendors into direct insight that only takes a couple of clicks. And now I'll hand it back over to Thomas.
So the summary of some of our key findings here, we really found that streaming is not influencing live attendance in any real way. The biggest determining factors on the numbers of ticketing sales or streams is really just the popularity of the individual sports. Our predictive forecasting suggests ticket sales not being negatively impacted and are actually increasing, and we predict that that's going to continue in the future. And then we have some prescriptive strategies suggesting that they should, WIAA, that is, should leverage streaming as a tool to enhance their ticket sales rather than viewing it as competition against it. Thank you, and do we have any questions?
Questions for the team? When I first spoke with the WIAA over a year ago about this project, I had never, I guess maybe in my lack of domain knowledge, I guess I'll say, high school sports and streaming was something that I hadn't even considered, right? So I guess first and foremost, where were you able to identify where, or maybe do you already know, where high school sports are streamed? Meaning, is it, when we say streaming, does that include like free television channels? Is it online platforms?
It's an online platform they have. The NFHS network has their own website, and then people can subscribe to that and then watch everything. They can select each individual events on there.
Oh.
So there was also, like, we actually went to a bowling tournament they had, and they had big screens there where you could see all the different events that were on the screens as well.
So it's like one platform specifically for that streams high school sports?
Nationally, yes.
Nationally, wow. So if you scroll onto the stream, if you access this app, then you can view sports anywhere from around the country?
Yes.
Wow. That's interesting. So then it brings up, what are the opportunities there, right? And I guess part of the question going into this, which you've addressed, was, is this having a negative impact on ticket sales? But as you said, it's not, right?
No, we're seeing no negative impact on their ticket sales at all. In fact, ticket sales have been increasing the last couple of years since they've had the streaming introduced.
Great. Did you identify, or did they have in plans to operationalize any ways to utilize or leverage that app then to increase ticket sales? Like anything actionable, or any suggestions or any ideas that your team came up with?
Well, I mean, they are considering some of the data from the streaming viewership to, again, see if some sports need a little bit more support. You know, they have good in-person attendance, and it's like, well, the streams that we do have are getting a good average number of views, and with continued support, we could see more growth in both ticket sales and streaming viewership if we had some more streams up.
Got it. So it might be a goal. So your dashboard will enable them to see which sports are getting less streaming views, and they can focus resources on those to increase that?
Yes.
Awesome. Last chance. Go ahead.
One other question.
First question that brought up that, is it a cost per game or is it a cost just to use the site or none at all?
It's just a cost per site.
Okay, and is it like a yearly thing or like one-time cost?
They monthly.
Monthly? Okay. Sorry. Second question, do you think that the increase in ticket sales is because of the return from COVID? So is it just because we are just now having in-person live events again? Have you guys already thought about that?
It looks like the trend is just continuously going up because even before COVID, it was following that same trend a little bit as well. Then when COVID happened, obviously, numbers all went down and then they've been climbing back up, but they are higher than they were before COVID as well.
Okay, I was just curious because we had that in our data as well, where the attendance was much lower during a time that they had opened another location. So just correlation that we had in ours too, so I was just curious.
Yeah, I was just going to say, you guys may have seen in the visualization, all the sports have been showing healthy trajectory in both streaming and ticketing. If you guys saw that it wasn't, it's because the data was just incomplete or we're in the season that they're currently competing.
That's all.
I'm fascinated that there's this national streaming service. I should have asked this a long time ago. So is it, so it's a monthly, it's a subscription model. Does the WIAA have to fund that at all? Or is it funded by users, subscribers?
It's funded by the subscribers and the NFHS.
Got it. Does WIAA, or is there anything in place where they receive more resources with a higher number of streams?
Yeah, they get like a pool of the revenue of the total number of streams.
Got it. Okay. Excellent. So that's how streaming, an increase in streams can benefit the organization. Awesome. Anything else? Yeah.
Yeah, so I was wondering, when you're looking at all the data, is there any way, so I'm not a big sports fan, so I might not be asking this correctly, but to tie in like how competitive maybe the sport is for that season and then relate that to the number of viewers? Like I would imagine like a championship tournament would see more viewers than say just like a regular preseason game, or I even think back, again, my limited knowledge of sports, I know there was a really competitive WNBA player that was introduced, I think, last year, and Caitlin Clark, I think that's right. Everyone's been watching a lot more WNBA. Have you thought about looking at that, or has your client thought about looking at any of that?
Well, the WIAA specifically does postseason, so they already do those high-level events.
Yeah, and you're totally right. Something that we noticed too that was kind of a limitation is that we noticed that there were highly competitive events that we had ticket data for, but not necessarily, or sorry, streaming data for, but not necessarily the ticketing data. And we didn't have access to that because of the venues where those competitions take place. The bigger events, they take place at places like the Tacoma Dome or the Yakima Sum Dome in Eastern Washington. But whereas less competitive games, they take place at their high school.
Any final thoughts or questions? Thank you very much. Thank you. All right, well, this concludes our presentation portion of our showcase today. I would like to say as one final note for those watching, we still are accepting project proposals for applied projects for next academic year. This is the students here in displaying this work are near the completion of the program in what might be the longest, fastest year of their life, potentially, but as they complete their 12-month journey, we have another group coming in shortly after, within a 1 to 2 week period of 60 students, and we would love to talk about any project ideas or opportunities for collaboration that you, the sponsor organizations in our local and distant communities might have. So, you could view, access the more information on our proposals on this website link about the Applied Project Program. There's a link there to submit project proposals. But more commonly, how these collaborations are initiated is with a brainstorming meeting with myself and people from your team at the organization to talk about the project idea that you might have and see if this is something that is going to be applicable, that our students can really dig into and co-create value with you on a data-driven solution related to your business problem. So those have been extended to June 13th. Again, all good things start with an idea, right? So even if any idea that you have, please reach out to me. I would love to discuss with you and members of your team and your organization about a potential applied project for next year. All right, so we will go ahead and break. This will conclude the live stream. Please join us in person from 1:30 to 3:30 p.m. Drop by. That's a great opportunity to stop and interact directly and engage directly with our students. Ask more down-in questions about their project. They'll have their project posters on display, and also to inquire about their journey, aspirations, and how they could maybe be of benefit to your organization in the future. So thank you very much, and we will resume at 1:30 p.m. In the hallway of Milgard Hall.